Hello, Dr. Tracy here, and we are continuing in our discussion of Boolean algebra. And this section talks about the canonical or the standard forms in Boolean algebra. So first, there's some terminology to know, and that's literal. It just means that it's adhering to a primary term or expression. So what that means is you don't have to calculate it. If it's a literal, then it's just as it is. So a literal can be expressed as a variable because it's an expression that's unchanging. So when we create an expression, we use these as literals. That contains 7 literals. 1, 2, 3, 4, 5, 6, 7, each one of those letters. And the multiplication and addition are representations of and, or, and the dash is a representation of not, which are the 3 possible ways to conduct Boolean algebra. So now, like elementary algebra, Boolean algebraic expressions are made up of groups of terms. So when we talk about product terms, and is multiplicative. That's why it's called product. So whenever you have x and y and z, that's a product term. These are terms, the sum of products is going to be when we take all of those product terms and we connect them with an or, we have the sum of products. Anytime you have an or, you're going to see sum. So min term, or the standard product term, is the product term that contains all the variables of the problem. And so, like in this example, it shows x, y, and z. X times y times z. Since we see times in there, we know it's a product, not x times y times z. Now, I could read this according to the way that Boolean algebra reads, which is x and y and z, not x and y and not z, and not x and not y and not z. Are all min terms because they're showing each of the values that could be possible using the ands and not. And so that's a standard product term. So the sum of min terms is the sum of all those possible products, which is shown here in this table of the 3 variables of x, y, z, which means all of their possible values. And of course, not x would be 0 and x would be 1 because we use 0 and 1 to represent true and false. So this is a notation that expresses the sum of all the min terms in any expression that we're basically talking about products, which is and. This and this and this. So when we talk about a sum term and the product of sums, see up here it was the product term and the sum of products. This is the sum term, and the product of sums means that we're talking about all the literals that are connected with or operators. And then in any way, when we connect those literals connected by or operators with an, we create a sum term or product of sums. So the canonical product of max terms, which is a product of sums in which each sum term is a max term since all the variables are present, and the canonical problem is given for a unique problem. Here is the truth table or the value table for the max terms. X plus y plus z, x plus y plus not z, x plus not y plus z, and these are all the possible values that can happen with the max terms and expressed that way. So min term and max term are just basically what we do when we have all the possible values using multiplication and all the possible values using addition, and this will come into play later. Hope that helps.